Hello, and welcome to today's class on Understanding Geography with Diagrams. Today we'll be talking about your temperate cyclone. First, we'll talk about what's the meaning of your temperate cyclone. Second, we'll be talking about the stages of formation. Third, weather associated with each stage. Last but not the least, your types of temperate cyclone. Yes, temperate cyclone do have types. Now, let's go for the first of all. Let us understand the meaning of cyclone. See, when I say cyclone, we basically understand that certain kind of a tropical cyclone. But actually, cyclone can be divided into your temperate cyclone and your tropical cyclone based upon their location. Your temperate cyclone is also called your extratropical cyclone or your wave cyclone. And your tropical cyclone is also called easterly waves. I hope you can figure out why your tropical cyclone is called extratropical cyclone. If you get it, please write it in the comment section. Now, the difference between your temperate and your tropical cyclone. First of all, location. Temperate cyclone is basically located in the temperate region. Basically, I would call this a region beyond your subtropical high. And your tropical cyclone up to your subtropical high pressure region. Next, the movement. Temperate cyclone moves from west to east and your tropical cyclone moves from east to west. Now, certain people might have difficulty in remembering how the tropical cyclone moves. Now, in this particular context, I can say that remember that whenever we have a cyclone that is being formed in the Bay of Bengal, it moves towards the Indian continent. So, what is the direction? West to east. I hope you get it. Next, formation. You can see that the temperate cyclone is formed because of your convergence of the warm and the cold air mass. Whereas the tropical cyclone is formed because of the low pressure where in the marginal water bodies where the temperature is between 25 to 27 degrees centigrade. What are the conditions? We'll be discussing it in another video. Next, now your temperate cyclone can be formed of the land and also can be formed of the water. What is in context of tropical cyclone? They are formed on, no, I think I wrote this in by mistake. They are formed on water and they move towards the land. So tropical cyclone, they are formed on the water and there they move towards the land. I hope you got a rough idea about the difference between the tropical and the temperate cyclone. Now I have a question for those who have watched my earlier videos. Do we have temperate cyclone in India? If yes, please answer in the comment section. If you say yes, then you have to write where do we have such a thing. Now, see, basically through this we got a rough idea of what a temperate cyclone is. Now from this itself, from our understanding, can we define what is a temperate cyclone? Let's go for it. Now temperate cyclone, basically I would call it as a cyclonic disturbance or a weather disturbance caused or located or formed where in temperate regions due to the convergence of the air masses with different temperature, in bracket cold and warm air mass. Simple. It's simple. This is nothing but, see, basically what I did was that first of all I brought out the difference, and from this difference only I got this meaning. I did not read any kind of book for this. I basically, from this point, I want to make you clear that understand the things and make your own definition, but please understand properly. Only if you understand properly, then only you can make a good definition. If you lack understanding, then definition would be compromised. Next, let's move on to the stages. The first stage is your frontogenesis and your last stage is your frontolysis. From this itself you can get that this is the stage where the front is being generated and this is the stage when the front is being dissipated. Now what I am saying about the front, I'll just talk to you while I will be discussing about the stages. Let's go for the first stage. The first stage is your frontogenesis. For the simplicity, we'll basically use the map. The map of what? My best, it's your North America. I hope your North America is not that good. See, this is your 60-degree parallel or the 60-degree latitude. We call it 60th parallel or you call it 60th latitude. Please, there is no difference in that. Now, what happens in this latitude is that there is the cold air mass over here. Why? Arctic. And then there is warm mass over here. Why? The maritime tropical air mass. Now look at this. This cold air mass over the Arctic, they make a movement from similarly there is a warm air mass which is moving from west to east. Now what happens in this context is that so basically what happens is that in the frontogenesis stage there is a stark difference. That is, the first of all, the cold air masses are formed in their respective area. Means the cold air mass is formed in this means this is the front. If I call this as a front, then cold air mass is formed to the north of the front, warm air mass is formed to the south of the front. As you can see, none of the air mass are intermixing with each other, but within a time process what happens is that there is a stark temperature difference. Over here what happens? Over here it becomes cold, and over here what happens? Warm, high pressure, low pressure. See, you do not need to mention this that there would be high pressure developing over here or there is low pressure developing over here, but you simply could understand that. Hence, it is because of the contrast in the pressure difference that will result in the movement of the cold air mass into the warm air mass area and the warm air mass into the cold air mass area. Let's understand this. Now, this is the second phase is called as that. I need to shorten this ink first of all. Yes. Second stage is called a division. What is the division of the front? The division of the front is simple. It means your cold air mass would be intruding to the space of the warm air mass, and the warm air mass will move towards your cold air mass. This is called your division of the front. Division of the front and beginning of the cyclonic circulation. And beginning of cyclonic circulation. Now, if you refer to my notes, in my notes I have written that what happens is that once the cold air mass intrudes into this region, the cold air mass will means this is your front, and here we have the cold air mass which have intruded your front. The cold air mass, what it will do is that it will witness the warm area towards its left. There would be a warm area towards its left, because obviously we know that there was warm air over here, and this is the warm air mass over here, and the warm air mass which has moved towards the higher latitude. And then hence when the cold air mass enters into your when the cold air mass enters into lower latitude, what it will witness? It will witness a warm area towards its left. And why will it witness? Weis-Bellot law. Obviously, why will it witness? You have the reason for it, and it will be witnessed towards its left. This reason was given by the Weis-Bellot law. Weis-Bellot law says that if the cold means that if the cold air mass is intruding from the north towards the south, it will be witnessing a warm core or the warm area towards its left. Now what happens? This will come to the third stage. Third stage is nothing but your quick shift of the cold front it's a quick shift of the cold front and closing down of the warm sector. Now I hope I'm not writing it down, I just said it, but I've just explained it to you. Now what happens is that once it witness a cold, so this warm air over it, now it will start beginning the cyclonic circulation. How? what it will try to do is that it will try to push away this warm air mass. The warm air mass would be tried and pushed away by the cold air mass. The cold air mass first of all will expand its reach and it will push away your warm air mass. The warm air mass will be shifted towards the up. Just understand this with a vertical diagram. I am drawing it. See, the cold air mass basically will cover the area, and as a result of which this warm air mass will move up, because it will push the warm air mass towards the up. Now the warm air mass is moving up, what will happen? Obviously precipitation. I hope you got that. Now then moving on to the fourth stage, that is your stage of OCCLUSION, occlusion. It means that the entire area would be covered by your, will go back again with the, it means that your entire area would be covered by your cold air mass. That is, the cold air mass would cover up to your entire area, and as a result of which what will happen? The temperature contrast would fall, means there would be a low temperature over here, means obviously winter over here, and that the precipitation would start to weaken. Because the entire, first of all, the entire warm air mass has totally been completely taken away by the cold air mass. Hence temperature contrast do not exist. Hence it's a pure area of a high pressure. Hence precipitation would start to weaken. And the fifth is your stage of frontolysis. Means simple, means that the temperate cyclone would completely dissipate. Dissipate means it would completely end of the temperate cyclone. So basically this entire stage, that is from your stage to the front genesis, to the division and the beginning of the cyclonic circulation, to the quick shift of the cold front and the complete occupance of the warm front, and the stage of occlusion to the stage of frontolysis. This is a time span of 15 to 20 days. I hope you remember that when I was teaching your jet stream, I had talked about the polar front jet. And what was the reason for the polar front jet, sir? It was because of the convergence of this, that is warm air mass and the cold air mass. I hope with this you got the stage of how the temperate cyclone is being formed. Next we would go on to the what was the next topic? Next topic was weather associated with the each stage. Actually, I'm very much sorry, but I tend to forget things. You can even ask any of my students. Now let's move on to the weather associated. Now to the weather associated, basically I would divide. See, first we know that in the upper latitude, what is this upper latitude? Means upper latitude means the area which is above your front. This was the front that where the convergence of the cold and the warm front took place. Now so basically I would talk about this area where there was warm front, this area where there was your cold front, and we'll talk about, first of all we'll talk about what was the weather when the front was not being formed. Then what was the weather in the warm front area, what was the weather in the cold front area, and then we'll talk about the occluded front. We'll talk about the occluded stage. So in each and every stage what happened was that the weather phenomenon was completely different. Hence first of all our was that in the stage of, or the frontogenesis stage, whether in the frontogenesis stage or in the stage front, what was the weather? See, in the frontogenesis stage, as we had discussed, that both the, that is warm air, the warm air maintained its limit as well as the cold air also maintained its limit. So basically this was marked with stability. However, there was a certain rise in the temperature in where, so, sorry, I have again made the mistake. this was your cold air and this is your warm air. See, in the very beginning of the stage, what happened was that there was your cold air and your warm air. Cold air was on the north, warm air in the south. So first of all, what happened was that there was no such climatic disturbances. Basically what since in the absence of such climatic disturbances, what happens is that the weather was calm. However, there was short temperature rise in the higher latitude and a short temperature fall in the lower latitude. What does this mean? It means that see, though the front is completely separate, but there are certain areas where what happened is that there was a intermingling of the front. I mean the first stage itself, in the stage of frontogenesis. And this intermingling of the front, what happened? That in certain areas, what happened? In the obviously this is the warm wind over here, and over here we have the cold area. So when this warm wind penetrated over here in the cold area, what happened is that suddenly there was a temperature rise in the cold area. Similarly, when the cold wind penetrated into the warm area, what happened? There was certain fall in temperature in your cold area. So this is what was called as the short-term temperature, that is short-term or short temperature rise in the higher latitude and a short temperature fall in the, or a short term, I'm sorry, I would be using short term. Short term means for a quite a few time. Therefore, a quite few time, there would be temperature rise where in the higher latitude and there would be temperature fall where in the lower latitude. This was in the frontogenesis. What else? Now this was also, now another one was the dew. Where would be this dew formed? The dew was marked where? Was marked in the lower latitudes. When I mean lower latitude, means the area of your warm front. Three things. First, calm weather condition. Second, a short-term temperature rise in the high latitude and the short-term temperature fall in the lower latitude. Last but not the least, formation of dew marked in means dew which is formed in your lower latitude. Next. Second, we have the warm front weather. Now, what was this warm front weather? Now, basically what happened was that now this area, there was a march of the warm air. Now this warm air had, number one, this warm front results in the formation of a taiga type of a climate. What is taiga type of climate? I will be teaching you taiga type of the climate when I teach you the Köppen's classification. But still then, if you wanted, you can go for the Google search. And then it also results in the formation of a tundra type of climate. What is this taiga type of climate? Taiga, you must have heard of the taiga forest, right? If you have heard of the taiga forest, then it exists in your 60th parallel. Taiga type of climate means that there is a 30 centimeter of rainfall throughout the year. And this 30 centimeter of rainfall throughout the year is caused by what? Obviously your warm front. Similarly, in the tundra type of the climate, there is a 20 centimeter rainfall. But when this 20 centimeter rainfall is none other than in your summers. I hope you got the difference. In the taiga, there is a 30 centimeter of the rainfall throughout the year. In the tundra, there is only 20 centimeter of rainfall, that too only in summers. So warm front weather results in the taiga type of climate, tundra type of the climate. But also remember that the warm front results in what? It limits the frosted. It limits the frosted region. What is this frosted region? See, we have the Arctic Circle somewhere over here, and the polar winds of the Arctic are very strong. Now, when the polar wind, now what happens is that this warm weather or the warm front, they actually limit the incoming polar winds. Actually, they limit that because the only certain part you can see that only though they come means the polar winds, they come into the territory, but It is this part, that this large part of the warm weather masses, that actually limits the excessive polar winds from coming towards the lower latitude. Hence, it limits the frosted region, or it limits your what? This frosted region is nothing but your polar desert in higher latitude. I hope you understood this, because it does not allow the excessive polar winds or the excessive polar climatic winds to reach to the lower latitude. Else, it would have resulted in the complete frozen of the higher latitude area or the temperate region. Rarely there would be the existence of a temperate region. This taiga and the tundra itself, they are nothing but your buffer. What is your buffer, or a middle zone, that is formed by what? By your this warm front climate itself. I hope this got clear. Next, let's move on to your third. Is, I'm changing the ink, even I am tired of looking at this black, is your cold front. Understand this cold front. Again, we'll go again for the map. Now most of you would be asking, sir, why the hell are you drawing this map of North America only? For simplicity and for the ease of understanding only, nothing else. Yes, we need to have a proper map, and we need to highlight over here the Gulf of Mexico, because we have a major region over here. See, now obviously both the warm front and the cold front, one thing they have common, that they are causing precipitation. Warm front is causing precipitation, cold front is causing precipitation. But again, within the precipitation there is difference. The warm front precipitation are intense, means they give more precipitation in the coverage of a small area. Means for every 40 kilometers there is 1 kilometer rise. It means that the warm air, once it covers 40 kilometers, it will rise up to 1 kilometer in the height, leading to precipitation. But there is a opposite in case of your warm front weather. Warm front weather is what? See, warm airs are in general, they are very calm and quiet. Hence, they cover a distance of 80 kilometers, then slowly and steadily they will rise and lead to precipitation. But over here, what happens in the cold front? Though it gives precipitation, the precipitation is intense. That is, they give more precipitation in less area. Warm front, what does it does? More precipitation in larger area, means more precipitation in larger area. But here, more precipitation even in the lesser area. So, with this understanding, one thing you also need to understand is that now the cold front, what they do is that they intrude up to a longer distance. Means you can, this is your Gulf of Mexico, this is your Pacific Ocean, this is your Atlantic Ocean. In your Gulf of Mexico, what happens is that these cold polar winds, they come in contact with your maritime tropical air mass, and this maritime tropical air mass will result in the development of a squall line. What is this? A squall line. A squall line is nothing but a region of instability, and this squall line results in your development of tornadoes. Where? In the Gulf of Mexico region. The Gulf of Mexico region therefore is classified as one of the tornado regions, and the reason being this, that is the convergence of the maritime tropical air mass with your continental polar air mass. And where does the continental polar air mass comes from? Obviously from your polar region. So with respect to the cold front, what we got? With respect to the cold front, number one we got is that precipitation intense. We have the intense precipitation, means more precipitation in less area, more PPT in lesser. No, see, writing more precipitation in less area is wrong. That it gives more precipitation. Please wait, let me frame the statement for you. It would give more precipitation with coverage with the coverage of lesser area. You can see, write this as 1:40, that for 40 kilometers there would be 1 kilometer rise leading to the rainfall. Second is that formation of a squall line where near the Gulf of Mexico and resulting in your tornado. What else? See, somewhere this cold front is also responsible for your lake snow effect. What is this lake snow effect? When this that is when basically we have the Great Lakes over here. Again, let me draw it. See, the Great Lake region, which is between the Canada and the USA. What happens is that within this Great Lake region, whenever this cold air mass are passing, they basically capture the moisture and results in the snowfall on the Appalachian. This is another of the phenomenon. Lake snow effect, squall line, and then it's your precipitation. Next is your last but not the least is your occluded front. What is this occluded front? Occluded front is nothing but the beginning, means that basically in the occluded front what we saw is that first of all the cold front had the complete coverage of the area. Hence, what will happen? Then first of all the precipitation decreases, and last but not least it will result in your declining or the beginning of the decline in the temperate cyclone. These are the two things that you basically experience with the occluded front. I hope it was clear. Now, what are the types of temperate cyclone? First temperate cyclone that we talked about was the dynamic. Now this dynamic temperate cyclone is nothing but the temperate cyclone that we talked about. Means it has been formed because of convergence of cold and warm air mass. Next we have here is thermal temperate cyclone. Now what is this thermal temperate cyclone? Thermal temperate cyclone is nothing but the temperate cyclone is formed because of a low pressure on land. Please understand this. There is a low pressure on land. Dynamic cyclone was formed because of your convergence of the cold and warm air mass, but over here it is formed because of the low pressure on the land. Here there is no convergence. But again you would say, sir, if there is a low pressure on the land, then why it is called temperate cyclone? Because it's formed in the temperate region. It's that simple. Next, we have your secondary. What is the secondary temperate cyclone? Very easy. Understand this. Secondary temperate cyclone is formed where? Over the ocean. How? When the cold air mass are moving over your warm ocean body. It's simple. We have your cold air, and then this is your warm ocean, resulting in your temperate cyclone. See, cold air mass moving over the warm ocean body, resulting in your secondary temperate cyclone. So these are basically your three types of temperate cyclone. Now basically I would like you to, and I would request you to write a question on what basically let's move on to our topic itself. We can get it. Yeah. What do you mean by a temperate cyclone? Describe the formation of the temperate cyclone. What are the weather associated with the temperate cyclone and types of temperate cyclone? And please add another one question. Difference between the warm front and cold front. Not weather, but warm front and cold front. Simple. I have given this in my notes. I hope you get that, and please write the question. I have to take my dog for a walk. Thank you.